Hi, welcome back. So before the break, we were doing some exam type questions. We continue with our exam type questions. I hope this is getting a little bit easier for you. Let's go. In this example, they gave us that TRS is a secant of the circle and SU is a tangent at U. Furthermore, they give us that TU is equal to 16 centimeters, TR is 12 centimeters, and T is equal to 41 degrees. We asked to calculate the length of UR, the size of U2, and the length of TS. Before we begin, let's first examine our diagram and see what information is given and how we can use it. Okay, so we have three triangles. First of all, they've given us a circle, so that's an indication that we're probably going to use circle geometry. We'll discuss what in a second. Okay, so they've given us three triangles. We have this triangle where we've got side, angle, side, which means we can use cos rule. This triangle here, we have no information at the moment. So at the moment, there's nothing we can do with a triangle. And there's a bigger triangle, triangle TUS. In that triangle, we've got one angle 41 degrees and one side 16. We don't have US and we don't have TS. So as we get through the problem, we probably need to find some other information, either using trigonometry or possibly geometry. So because we have a tangent, we've got to remember our tangent theorems. One of the theorems we can remember from geometry is that radius is perpendicular to the tangent, but there's no radius given here, so we're probably not using that one. We do know the tan chord theorem, and because we have a tangent and a chord, we're probably going to use the tan chord theorem at some point. Let's see how that happens. Okay, first we're going to find UR correct to two decimal places. This is pretty simple. UR is in this triangle. We've got the V pattern across from it, so we know we're using cos rule. So that's pretty simple to write out. So UR squared is going to equal to, we can start with the first side squared, 16 squared, and then 12 squared. 2 times 16 times 12, and because we're dealing with UR, the angle across from UR is 41 degrees. So we've got to plonk that in. Okay, we're going to put that into our calculator. We're going to end up with UR squared equals to 110,19 degrees. Again, we want UR, so we're going to take the square root of this. Taking the square root of this, we'll get the answer to be 10,50 centimeters. Okay, so now we have a value for UR. UR is 10,5 centimeters. Right. The next question, they want us to calculate the size of U2. Remember, we calculated UR 10,5 centimeters. Now they want us to find this angle here. Okay, now remember, we've got this value here, 10,5. So in this triangle, we've got side, side, side. So we can use, because we have side, 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 we can use cos rule to find U2. And remember, because we're finding U2, we're going to start off our cos rule with the side that lies across from U2. And if you look at U2, the side that lies across from U2 is TR. So our expression is going to start off with TR squared. Okay, so we're going to write our cos rule out. Okay, so we're going to start up our cos rule with 12 squared because we wanted the side across from UR. Because we wanted to start with the side across from UR, because from U2, because we are calculating angle U2. Okay, so which other sides do we put in between? The other ones that we haven't used. So we're going to start off with 16, okay, and then 10,5, what we found earlier, and again 16 here, and again 10,5 in here. Okay, now remember again we're solving for U2, so we're going to have to do some algebra to make U2, cos of U2 the subject of the equation. So we just got to do a bit of algebraic manipulation here, bring that onto this side, take everything else onto that side, and now we're going to divide by whatever is not U2 because we're isolating the cos U2 part. We're going to put this expression into our calculator with shift cos. So once we put shift cos and this entire expression into our calculator, this expression becomes 127 over 192. That's from your calculator, and now you're going to find the inverse, shift cos of 127 over 192, and we'll get the answer of U2 being 48,59 units. So what we found, because we had three sides, we found this angle here. This angle, 48,59 degrees. Now, because this question continues, we're going to be needing this answer for the next part of the question. Okay, so now I've just put it into the diagram. That's what we just found. Okay, they want us to calculate the value of TS. So they want us to calculate the value of TS, that line there. Now, in order to find TS, it belongs to the big triangle. We're missing a couple of things, aren't we? So we have, in the big triangle, we've got this side. If we can find these angles in the big triangle, it'll really help us. So now remember again, we said we're going to use some kind of geometry here, and we can already see that this angle, U3, using geometry, has to equal to 41. And the reason for that is 10 chord theorem. So that's 41 degrees. Okay, now because we have the other two angles in this big triangle STU, it's quite easy for us now to find angle S. So let's write that down quickly. Okay, so we said U3 is equal to 41 because of 10 chord theorem. Okay, U2 plus U3 now together, these two together, will give us 89,59. We're going to use that now to find angle S. So angle S will equal to 180 minus 41 minus 48 minus that amount there. So S will equal to 49,41 degrees, just using the angle sum of a triangle. Now we're going to apply sine rule to this big triangle STU. So let's begin. Remember, we are looking for the length of TS. So because we're looking for the length of TS, we're going to start with TS, and then we're going to use the sine of the angle across it. And the sine of the angle across from TS is that angle there. So we're going to say sine of 89,59 degrees. So the other full pair we have in the big triangle, remember it's 16, and the angle across it. And then angle across it was the angle S that we just found now, which was 49,41. So it's going to be 16 over 49,41 degrees. Okay, now we're going to rearrange that to make TS the subject of the formula. So it will be 16 times sine of 89,59 degrees divided by sine of 49,41. Put that into our calculator, and we end up with TS being approximately 21,07 centimeters. Okay, our next example, we needed to show that ABCD is a trapezium. Sorry, they've given us ABCD is a trapezium. We've got parallel lines. AD is parallel to BC. DAB is 90. BCE is 150 degrees. CD is produced to E. F is a point on AD such that BFE is a straight line, and CBE is alpha. So they've given us, this is alpha. They've then given us the angle of elevation from E to A is theta. They've given us this side is x, BC is x, and they've given us CE is 18 minus 3x. Okay, they want us to calculate to find BE equal to AB, to show that BE is equal to AB cos theta of sine of alpha minus theta. So we're going to go and look and see where is BE, which triangle does BE fall in, and we're going to try and solve that. Okay, so we need to show that BE is equal to AB cos theta over sine of alpha minus theta. So we have some things we need to do, some kind of decide which triangle we're going to use to solve BE. So first we're going to try and look at what had they given us. They've given us parallel lines, and because they've given us parallel lines, this angle and this angle must be equal, which means this angle has to be alpha because it's corresponding. And because that angle is corresponding, we are trying to find something with BE. So we're probably going to look at BE in one of the triangles, but we need to find some other angles. We can also find the value of E1 in terms of alpha and beta, because if you notice, this angle is an exterior angle of this triangle. So alpha is the exterior angle. So in other words, I can find an expression for E1 using alpha and theta if I need. So remember we said F1 is equal to alpha because it's corresponding angles. Okay, and F1 is equal to theta plus E1. And so therefore, E1 is equal to alpha minus theta. Now we're going to need that information when we continue with the example. Okay, so in triangle ABE, BE and the angle across it, so we're going to use sine rule. So BE and sine of the angle across it. Now remember this angle is 90 plus theta. So this angle is 90 plus theta, okay, equals to AB and the angle across it. And the angle across from AB is this angle here, so it's going to be alpha minus theta. Okay, because remember we're trying to find BE, so we're starting to find BE, and that's where we ended up. Okay, so we ended up there. BE is equal to sine of 90 plus theta, BE over sine of 90 plus theta equals to AB over sine of alpha minus theta. Remember again, this is going to remind us of our co-ratio rule, so we're going to have to change that in a second. Okay, so if I multiply both sides by sine of 90 plus theta, and the next step I'm going to change it to my co-ratio, sine of 90 plus theta becomes cos of theta. And now I have an expression for BE. And BE is equal to AB cos theta sine of alpha minus theta as we needed. Okay, so the next thing is show that the area of BCE is equal to the expression on the right hand side. Okay, so basically we want to find an expression for the area of BCE. Now if you notice in the triangle, in triangle BCE, we've got this to be x. We've got a value for this because this is 18 minus 3x. This length of EC here, so this one here. So we have that, and we have that, and we have the angle in between. So we're going to use that to write our area rule, which is pretty simple now. Area is equal to half x, so x times 18 minus 3x times sine of the angle in between, which is 150 degrees. We're going to put all the numbers and do some algebra and put it into our calculator. So sine of 150 is a half, and then put that into the calculator. Let's just first multiply half times a half. We get a quarter. And just doing some algebra, a quarter of 18 is 9 over 2, and a quarter times 3 will give us 3/4. So we end up with the area of triangle BCE is 9 over 2x minus 3, and then we've got x times x, so it's x squared over 4. So have we answered the question? Yes, we did, because our expression matches the question that was asked. Okay, so that was a pretty intense session. We did a lot of work. I hope this helps you to understand how to approach an exam type question, and hopefully you'll have fun practicing from now on. Thank you for joining me. Bye.